This lesson is on how to solve consecutive integer problems. First of all, let's talk about what consecutive integers are. For example, some consecutive integers could be 7, 8, 9, 10, and so on. Consecutive integers have a difference of 1 for each number. Let's look at our first example. The sum of 3 consecutive integers is 66. Well, the first thing we should do is try to identify our consecutive integers. There's 3 of them. Now, we don't know what the actual numbers are yet. So let's call the first consecutive integer, we'll call that n. If that's the case for the first one, the second one must be 1 more. So the n plus 1, and the third one be n plus 2, because consecutive integers differ by 1 every time. Now we can set up an equation. Sum means the answer to an addition problem, so we're going to take the first number, n, plus the second number, n plus 1, plus the third number, n plus 2, and that has to have a sum of 66. Now we're going to solve this equation. What we're going to do is combine like terms. We're going to solve this equation by working backwards using inverse operations along the way. And I'm going to finally divide both sides by 3, and I get n is equal to 21. So the 3 numbers are 21, 22, and 23. We found the 3 consecutive integers. We could do a double check just to make sure they add up to 66, and they do. Now let's try a problem involving consecutive even integers. Now, consecutive even integers would be numbers like 2, 4, 6. Consecutive even integers have a difference of 2 every time. And we're looking for 2 numbers that have a sum of 42. So first, let's identify our numbers. If the first number, which is unknown, if we call that n, the second number, because it's going to be a consecutive even, would have to be 2 more than the first number. And we have the sum of those 2 numbers is 42. Now I'm going to solve this by combining like terms. Start to work backwards. Oops. Almost wrote an M there. Equal 40. Divide both sides by 2. I get n equals 20. So the 2 numbers that we're talking about are 20 and 22. Those are the 2 consecutive even integers, and they have a sum of 42. And the last problem we're going to look at, this one here, says there are 3 consecutive even integers. There are 4 consecutive even integers. 4 times the largest number is 42 more than the sum of the 2 smallest numbers. Find the second largest number. Goodness. Well, we got to identify some key parts of the problem. Is a good indicator. This is going to be an equal sign. This is going to help us write in our equation. First, let's identify our numbers. And we know there are 4 consecutive even integers. The first one we don't know, so we're going to call that n. The next one is going to be n plus 2. The third one is going to be n plus 4. And the fourth one is going to be n plus 6, because consecutive evens differ by 2 every time. Now it says 4 times the largest number. Now the largest number is n plus 6, but we have to put that in parentheses to show we're multiplying 4 by that entire number. And that is, so there's the equal sign, is 42 more than the sum of the 2 smallest numbers. Well, the sum of the 2 smallest numbers would be represented by this, and we have 42 more than that. There's our equation, and now we have to solve it. I'm going to apply distributive property on the right-hand side. I'm also going to combine like terms on the right-hand side. Now, I need to gather all of the variables on the same side. I'm going to do that by subtracting 2n from both sides. And we continue to solve. I'm going to subtract 24 from both sides. Get 2n is equal to 20. Divide both sides by 2. Get n equals 10. So the number should be 10, 12, 14 and 16. And just as a double check, 4 times the largest number is 64. That's supposed to be 42 more than if we added up the two smallest numbers, which was 22. That's checking out. The problem said, what's the second largest number? The second largest number is 14.